All right, hey everyone. This is desired sample size, and it's going to be pretty quick. We are just going to look at how you pick a desired sample size. There's examples all over the place. I don't think I really need to work them. So on that note, let's just go ahead and see what we've got going on here. All right, so you got to remember as you write a confidence interval what the part of that formula is that represents your margin of error. It's the z star times the p hat times 1 minus p hat over n, square root of that. Excuse me. And this is just leaving out the sample estimate part. All right. The z star is determined by the confidence level. P hat comes from well, we'll see. This is going to be interesting. And the margin of error is what that is. Okay, if we are conducting a study and we are trying to limit our margin of error, we will not actually know p hat ahead of time because we won't have done our study. So we're going to have to do a little bit of finagling to get a value for p hat. Now remember, that was in itself was a finagle for not knowing the true population p. So get ready. Here's just another version of the letter P that is a part of this section. So since we won't know P hat, our sample estimate, because we haven't started our research yet, therefore we haven't sampled anything, since we won't know that value when choosing our sample size, we need to guess. All right, that's going to create a P star value. Yes, another letter P and another different designation. We have two options. You can use a P star based on a pilot study. Now, a pilot study is just a little quick study that you do that is really just a small variant of your actual research, designed just to see how this whole thing is going to behave. So it's going to be based on a pilot study or on some value that you've seen in the past. Or if you don't have any reference to a pilot study or on past experience, you use 0.5 as a guess. The reason you do that is because the margin of error is largest when p star equals 0.5. I believe we saw that with binomial distributions also, that when we used a probability, fixed probability of 0.5, remember we got a symmetrical probability histogram and it had the biggest spread. So it'll give us the largest sample size, which is erring on the side of too large, of all other options. So erring on the side of caution. Better to have a sample size that's too big than too small. Any other p hat would give us a margin of error smaller than planned. So here we go. This is our final formula. The original one was just an equal to here. So this has to be greater than or equal to z star from our confidence interval or confidence level, p star from either a pilot study, past experience, or 0.5. Right? 0.5 is your fallback. They will mention the prior study or they will mention prior knowledge in the problem. It's not going to be something you won't know. All right, now this little bulleted point here, use P5 if you expect P hat to be between 0.3 and 0.7. For more extreme values, below 0.3 or above 0.7, use a P star from a pilot study. Now look, that particular bulleted point is fine, and it's going to be a good thing to know if you conduct your own research. We're not going to conduct any research, so for us, really, it's going to be 0.5 or something from prior knowledge or a pilot study. Okay, now there is an example in your packet, and it's about, let's see here, get this out. It's about Gloria Chavez and Ronald Flynn. This is on page 5. These are candidates for mayor in a large city. You're planning a sample survey to determine the percent of voters who plan to vote for Chavez. You will contact a simple random sample of registered voters in the city. You want to estimate a population proportion with 95% confidence and a margin of error of no greater than 0.3. Okay, that's where 3%, so that would be 0.03. What large of a sample do you need? Okay, all right, now they don't mention a pilot study and they don't mention a prior value that you've seen in the past. So we're going to go for the 0.5 default, all right? So 95% is 1.690. That's your 3%, and we're trying to figure out n. So algebraically, you need to be able to do this. Okay, this is how I did it. This is not necessarily how you have to do it. Frankly, I do this a lot quicker than I'm showing you here. But remember that 0.5 times 0.5 is 0.5 squared, and the square root of that is 0.5, right? So if you imagine the square root being chopped into two, one in the numerator, one in the denominator, the square root of 0.5 squared is just 0.5, all right? N is still going to stay under the radical. All right, 1.960 is also a fraction. It's over 1. You just don't see the 1. So you can multiply 1.960 to the 0.5 and get 0.98. Okay, multiply each side by square root of n, divide by 0.03, and you get square root of n is greater than or equal to 32.6667. Okay, at this point, this is where kids make their most mistakes. Right, you undo a square root with a square, but I see kids undoing a square root with another square root, which is not right. Okay, so square both sides, n is greater than or equal to this. Since this does not represent a countable number of people in your survey, go up. Just go up. Don't round down. Bump up. If it comes out as an exact integer value, you can leave it. But if it's not, if it's got a decimal part, bump up. All right. You need a value at least this much or higher, so we're going higher in order to be within the margin of error. If you get smaller, you will be inside that margin of error and it won't be accurate. Okay? All right, now I added a second section here where they did a pilot study and they got 0.44 interested in voting for Chavez. Okay. So that just changes the 0.5 to 0.44.56, and you just run it the same way. Now notice that you get a smaller sample size in the end. Well, that's just because the conservative here gives you the biggest you'll ever get. All right? So anything that you use from a pilot study is going to give you something smaller. That's it. That's what we're going to do. We are going to work some of these desired sample size problems in the next 2 pages in class together just to get the practice. There's some textbook items. This goes reasonably quickly. So do that, and we should be ready to start doing other kinds of inference where we're going to test claims, and we'll start that on Wednesday. Okay, so there we have it. That's it. That's all I've got for you today. I'm going to sign off, and I will see you when I see you.